Chapter 7 is largely focused on the reactions of alkyl halides, or haloalkanes. But the first thing we want to do is learn how to name these. Now, it turns out the naming of the haloalkanes is actually fairly easy. And it essentially follows exactly the same rules that we had just for regular alkanes. First thing we do is determine the longest chain of carbon atoms. This provides the base name of the alkane. If there are two identical substituents, we pick the chain that has the most substituents. We have to decide how to number the chain. And same rule as before, the number of the chain is going to start on the end that gives the first substituent the lowest number. If there's a tie, and this is particularly relevant in cyclic compounds, then the substituent that comes first alphabetically gets the lower number. And then finally, we give the number and name for each substituent alphabetically. And then if there's more than one of the same substituent, we use the prefixes di, tri, tetra, penta, etc. And again, we don't use the prefixes di, tri, etc. when we alphabetize it. So the only difference is when we have alkyl substituents, right, we use names like methyl and ethyl, we treat our halogens as substituents, and they get the names fluoro, chloro, bromo, iodo. All right, so let's look at a couple names, or a couple examples of naming these alkyl halides. So the first thing we have to do is find the longest chain. So I think 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Doesn't matter which way I go. In each case, I've got an ethyl and a 7 carbon chain. So I need to decide which end to start numbering from. So if I go 1, 2, 3, the first substituent is at 3. 1, 2, 3, the first substituent would be at 3. So then the tiebreaker, this is an ethyl versus a fluoro, so E comes before F. So my numbering is going to be 1, 2, 3, 4, 5, 6, 7. Right, I have an ethyl group, a fluoro, 2 fluoros, so it'll be difluoro. So I have 3 ethyl, 4, 5 difluoro, and then 7 is heptane. Okay, here's another example. I think we need to be a little bit more careful on this one of determining the longest chain. It looks like I have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. So I think I like this as my longest chain of 7. So I need to start numbering from this end or this end. If I start numbering from this end, then my first substituent, this methyl, would be at 3. This end, the chlorine, would be at 1. So this end gives the lower number, the first substituent. So this is going to be my carbon 1. So I have 1, 2, 3, 4, 5, 6, 7. I have chloro. This is an isopropyl and a methyl. So I need to put these in alphabetical order. So C, we do use the I in isopropyl and methyl. So our compound is going to be 2 chloro, 4 isopropyl, 5 methyl, and this is another heptane. Okay, last example. Now we have a cyclic compound. So I have 5, so this is going to be cyclopentane. I need to decide the numbering. And so remember, we want the substituents to be as low as possible. So if I were to start here at this methyl, I'd have substituents at 1, 2, 3, and 4. So I'd have 1, 3, and 4. If I went the other way, same way, 1, 3, and 4. So I think I want to start from one of these guys, right? So I could get 1, 2, 3, 4, or 1, 2, 3, 4. So then to break the tie, I would use alphabetization. So ethyl, E comes before iodo, I. So my numbering is going to be 1, 2, 3, 4. All right, and then I have an ethyl, iodo, methyl. So E comes first, then I, then M. So I have 1 ethyl, 2 iodo, 4 methyl, cyclopentane.